Hello and welcome back to Cool Computer Science. And in this video I would like to talk about data types and variables. The goal is to introduce what data types and variables are. Well, there are three different categories for data types. The first category is an integral data type. These are data types without decimal places like 1, 2, 3, 500, 7,000, numbers like that. The other category of data type is a floating point. Floating point are numbers with decimal places. For example, 2.4, 3.7, 500.98. And the last category of data type is the enumerated type. These are user-defined data types. And these enumerated data types I will not be discussing in this video, but I will discuss in another video. The integral category of data type refers to three different data types. The first data type is an integer. An integer consists of 4 bytes, and remember that a byte is 8 bits and has this range. Normally when you declare an integer, it is signed, not unsigned, unless you specify unsigned. Notice that to call an integer in C++, to specify something as an integer, you have to use the keyword int. And keywords in C++ are case sensitive. The second type of data type is a character. A character has a size of 1 byte or 8 bits and is normally signed. And signed values -128 to 127 represents everything on the ASCII table. In other words, everything on your keyboard. And the keyword for character is char, and it is case sensitive. Boolean, the third data type, Boolean and bool for its keyword. And then we see that its size is 1 byte, which is 8 bits, and the value can either be true or false. True is a 1 and false is a 0. So just to recap, to specify one of these three data types in C++, you have to use its special keyword, which is int for integer, char for character, and bool for boolean. And remember that these keywords are case sensitive. The next data type category that we discussed was floating point type. The first data type in the floating point type category is float. Float is a floating point number, size of 4 bytes, and has a range of plus or minus 3.4 to the power plus or minus 38. The next data type is double, and as the name suggests, its size instead of 4 bytes is 8 bytes, and its range will be plus or minus 1.7 to the power of plus or minus 308. Next, I would like to talk about two ways of memory allocation. The first method is by creating a variable. A variable is a memory allocation whose content may change during program execution. For example, you may decide to allocate some memory for an integer and give its value of 5. Later on in the program, you may decide to change the value of this integer to 6. The second type of memory allocation is a constant. A memory allocation whose content cannot change during program execution. Again, with the same example, if you decide to declare an integer and give it the value 5, throughout the program, it's going to keep that value of 5. Now let's try this out in C++. Okay, I have a simple C++ file set up here. I have my header file, pound include iostream, and the reason for this is that I will like to output different things to the screen, and the cout object is in this header file. Also, I have specified using namespace std, which allows me to use cout in a nicer way. And I will talk about namespaces in another video. Also have the main function, which is necessary in order to tell the computer where to begin this program. And right before it returns, that is closes the program, I tell it to pause, which allows us to take a look at our results. Okay, so let's allocate some memory space for an integer. To do that, we will use the keyword for an integer, which is int. We will give this space a name. I'm going to call it num1, and I'm going to set its value equal to 5. And now let's print this value, but let's print this value using num1, the name of this space. So to do that, I'm going to say I'm going to give it a name called variable num1, cout num1, and I'll move the cursor to the next line by specifying end line semicolon. Okay, let's see if it's correct. Okay, so it works fine. Let's try one for a character value. So I'm going to say char, which is the keyword for a character. I'm going to give this memory space a name called char1. I'm going to set it equal to a. Notice that characters, I use these single parentheses here, and that specifies a character value. And I can use any character value that I like. So anything on the keyboard, semicolons, the @ symbol, the ampersand. I can also use capital letters, numbers, things like that. So let's output that to the screen and see if it works. One, and just compile and run, and it works great. So let's try a double. And I'm going to call this dub1, set it equal to 2.45. And I'm also going to declare a float. And I'm going to give its name float1. I'm going to give it a value of -1.2 semicolon, and then I'm going to also declare a Boolean value, and its keyword for Boolean is bool, and I'm going to give it the name flag, and I'm going to set it equal to true. Notice that true is a keyword, or you could say reserve word. Keyword, reserve word is the same thing. And that true is all lowercase. So if I have here a uppercase T, it won't read it as the keyword true. So now let's print all of this stuff to the screen so that everything works. For the double, now for the float, now for the Boolean value. And let's run it. And it works great. Notice that when you want to print the Boolean value and it gives you 1, it doesn't give you true. Likewise, if I said boolean value appears false, it will give me 0 down here. And let's try something else with character. Let's use a symbol. Like I said, you can use symbols, so let's try this symbol here. And it works. And you can an ASCII table, there are also special characters that allow you to do special things like inserting a new line. You can do that by using \n. Let's see if it will put that out. And it does, see? It puts a new line between, it says character 1, then it puts a new line, and then you get the double value. Now, do you have to have a value declared when you allocate memory? No, you don't. In fact, I can delete all of this. And when I run the program, I just get some garbage. So, I mean, it doesn't mean anything. So how do you declare give value to that memory you allocated? Well, you can do that by saying num1 equals 6. So I'm just going to remove all of these because they don't have anything in them important. And yes, we're missing a semicolon here. And it works. I can allocate memory down there. So let's say I have another integer value. I'm going to call it num2. And I say that num2 equals 7. So I'm going to say 6 plus 7. 6 plus 7, which is num2. Let's see what it'll give us. Ooh, that's not the result that we wanted, right? So let's see why. The reason why is that the system will run straight down. So first it looks at num1 and assigns it a value. And at this point in time, num2 doesn't have any value to it. It just has a bunch of garbage in that location. So in order to correct that, you simply move num2 up here above num1, and when we run it, we get 13. 6 plus 7 is 13. So what this shows us is that the location where we declare a variable is important. So let's talk about the other type of memory allocation we talked about, which was constants. And the way a constant works is, suppose I have num2 equals 9. Right before I specify int, I'm going to say const. C-O-N const. And what this does is that this says num2 is a constant, so it cannot be changed. But look at this down here. I'm going to try and see if I can change it to number 7. Let's see if it'll allow me to do that. And no, it doesn't. It says, well, depending on your system, they'll say different things. So my own says assignment for read-only variable num2. So you can only read it. So I remove this, try and run it again, and it works great. Num2. 6 plus 9 equals 15. So this concludes this video on data types and variables, and I encourage you to play around with this some more, and thank you for watching, and I hope that you enjoyed this video.